What's up guys, in this tutorial I'm going to be showing you how to implement object-oriented programming in polymorphism in C. So C doesn't have a built-in system for polymorphism or objects, so you have to implement everything manually, and you can see how this can get pretty messy. So if you're planning on doing anything extensive, I'd recommend using Java or C++ or any other object-oriented language. So today we're going to do a simple example of a shape class. So we start up here with the UML class diagram of shape.if with a getArea function. We have a shape class, an object shape class, and then rectangle and circle extend it, and then further ring extends it. And these all have their own versions of the functions that we're going to implement. So this tutorial is going to assume that you have knowledge of memory allocation, typedef, structs, function pointers, basic stuff like that in C. Alright, so let's get into it. Alright, so I've made a shape.c and shape.h file. So first we're going to make the shape interface. So make a new struct for shape.if. And now shape.if just only has one function pointer inside of it. That's the getArea function. So make a function pointer. And that's going to take in, it should take in a shape, but we haven't defined shape yet, so we'll just make it a void pointer. This is going to give us some warnings in the future, but that's alright for now. It should be alright when we automatically cast the void pointer to a shape in all of our shape functions. So now we make our actual abstract shape class. And then a shape has a type. It's a string. It has a void pointer to the object that extends it. And now the reason this is a void pointer is because we don't know what types of objects are going to extend a shape. So we make it a void pointer so that we can cast it as needed in the future. And then it also has a shape.if, so we can access the functions from shape.if. We'll actually make it a pointer to a shape.if so we can share this shape.if object with instances of shape. So that's it for shape. We actually do have a shape function that's a constructor, but we'll just make that a static function in the shape.c file so that it can't be accessed outside of that file. Since it's abstract, we don't want any instances of shape. So now we'll make our rectangle. So a rectangle has a double length and width. So notice in the UML diagram, we didn't have any class that extends rectangle, but I'm including this just in case in the future we wanted to add anything that extends rectangle without modifying this code, the rectangle code. So this code is flexible in the future. So then it also has a shape.if, so we can access the shape functions. And it also has a reference to the shape object too. Okay, so now we need our rectangle function, so we'll do a constructor. So return a pointer to a rectangle. And this will take in two doubles for the length and the width. Next we'll do our getArea function, so double rectangle. And this will take in a shape object. So those are our rectangle functions, and then we'll make our circle class now. So a circle is similar to a rectangle, but it has a double radius. It has an instance for the same reason as rectangle. It has a shape.if. It has a shape. Now circle has additional functions, get circumference. So we could just make a function pointer inside of here for the get circumference method, but I want to follow the same standard that I did above with having the rectangle or the get area inside of the interface. So I'll make another interface here for circle IF. This will also allow me to have multiple functions that can be pointed to by circle and any classes that extend circle. So this will save memory. So we'll just have a double function pointer. This will take in a shape. Alright, so now we just need our circle functions. Just gonna copy these right here. They're very similar. Circle. Circle constructor only needs one double for the radius. And then it has the same parameter as a shape object. And then we also need our get circumference. It also takes in a shape. So the reason we use a shape object for all of these functions is that we want them all to be called from shape. So we need them to take in a shape object without knowing the type of classes that extend it in order to call the function. So now we'll start implementing all these functions. So I'm just gonna copy these into our shape.c. So first we need to make the shape constructor. So make this static so it can only be accessed within this file. Return a shape and shape constructor. And this will just take in a, if I can spell it right, type. Okay, so first we're gonna allocate memory for our shape. Alright, so now we're going to also allocate memory for our shape IF. Alright, so now we just set the type of shape. So notice that we didn't set the function pointer to any function for shape IF. That's because there is no function for shape for get area. So now we just return S. Alright, so in our rectangle constructor, it's pretty similar. Now, rectangle. We'll name these variables length and width. So now this is going to be similar to calling the super constructor in Java or something like that, or base constructor in C#. But we have to do everything manually, so you can see how it can get very complicated. So we're going to do shape, call the shape constructor, we're just going to pass in rectangle. Now we need to assign the function pointer, so it's shape IF, and now get area equals the address of our rectangle. And now this is the warning it's going to generate because it's a void pointer because shape wasn't defined yet. So we used a void pointer for this parameter, but this rectangle get area is a shape. But this will be okay because it'll cast our void pointer to a shape. And this will only be called from a rectangle, so there should be no issues. So now we want to link these two objects together. So S instance equals R shape equals S. And now we also need to have the rectangle's shape IF point to the same shape IF as S. So okay, great. So now we just need to assign the length and the width. W, and then we just return R. That should be everything. So now if we want to use a rectangle object, to get the area of it. So we have a shape here that's passed in, and now we need to get the rectangle object in order to access the length and the width. We can't just do S instance because this is a void pointer, and first we have to cast it. So we're going to make a new rectangle. And then we're going to cast S instance to a rectangle pointer. So now we can just return the width times the length for a rectangle. So that's everything for a rectangle. So now we just need our circle functions. So I'm just going to copy these over. Double R. So the circle constructor is really similar to the rectangle constructor, so I'm just going to copy it over. Size of circle. I'm going to pass in circle instead. This will change to circle.getArea. Now we can get rid of these, return C. Now we need to set the radius instead of the length and the width. Oops. Okay, so now everything's set up except for circle also has a circle IF object that we need to allocate memory for and assign the function pointer to. So we'll do C, similar to how we did in shape. Circle IF. Size of circle IF. Oh, I forgot to add it here. There we go. This should go away in a second. Okay, so C equals the address of circle. Oops. Alright, so that's everything for our circle constructor. Now in our shape construct or our circle get area function, it takes in a shape, so we need to cast it again. S instance. Now we can just return. We're going to approximate pi to 3.14 times C radius. All right, and then the circumference is pretty similar. Except we're going to return 2 pi r instead of pi r squared. All right, so that should be everything to test out our rectangle and circle functions first. So if we go into main, this is how we use our newly created objects. So I'm just going to make an array of shapes. So I'm just going to make 3 shapes here. And then shapes 0 equals, we'll make a rectangle. Rectangle constructor, and we'll pass in 10 and 10. Now this returns a rectangle object, and we need the base shape object. So we'll do the rectangle object's shape, or not base, shape. So this is how you would cast it to a shape. So I'm just gonna do something similar here. And obviously in other languages, this is automatically done for you. But you'll see how here it's more complicated because you have to handle everything yourself. So we'll just do 2.5. Do another rectangle 1.5 and 1.5. And now if we wanted to print these all out, printf, type, and the area, round it to 2 decimal places. And we'll do shapes. In order to get the type, shapes I, type. The array holds all shape objects, so we have access to the type variable. And then we want the area, so we do shapes I, and then the getArea function is in the shapeIf object of the shape, and then getArea. And then we have to pass in a reference to itself, which is a drawback of doing this type of thing in C. It's a little more complicated because you have to pass in the reference to itself every time we want to perform an operation on it. All right, so if we run that, oh, that's because I didn't change the index. Great, so everything worked good. All right, so we have a rectangle and our circle, and now we want to extend circle to have a ring object. So we'll go back to our shape.h. So we're just going to make another class, or struct, for ring. Now ring is going to have a second radius. It's going to have an instance in case we want to extend it further. It's going to have a shapeIf. It's going to have a circleIf too, because it also has a circumference function. It's going to have a reference to our shape and a reference to our circle. Okay, so the functions are going to be pretty similar to circle, so I'm just going to copy them over. That's a ring. Now a ring constructor. It's going to take in 2 doubles for both radiuses, or radii. And now we're going to do alright. So go under ring.c. I'm actually going to copy these over. Or shape.c, I mean. In our ring constructor, you're going to see that we have to do a lot of things in order to get this to work. So this can be where it becomes inefficient. So R and R2. So we'll do ring equals then we're going to call the super constructor to get the circle object. And circle is also going to call the shape constructor too, so we'll have a circle and a shape returned here. Equals C equals. And then we're going to pass in the first radius. So now we're going to link these objects together. So we'll do circle F. I might have, oh, circle F here. Alright. Should go away in a second. Okay, so now we're going to assign the functions. Oh, also we need ring equals C shape. You can see it can become very easy to forget things. So if you wanted to even extend this further, it'd be a nightmare to link everything together. So circle IF get this is the address of alright, and then equals the address of ring area. Alright. And now we're going to do ring 2 equals R2 and then return ring. That should be everything. So now in our get area function, it's going to be pretty similar to circle. If we're just going to subtract the two areas, or the absolute value of the two areas. So first we need our circle object to get the first radius. Circle s instance, just like before. Now we also need to get the ring object because ring is what holds the second radius. Ring R and C instance. So now we'll do double area equals 3.14 times C and we're going to subtract 3.14 R and then radius 2 squared. And now we'll check if area is less than 0. Return -1 times area. Then return area. Okay, so circumference, we're going to do the same thing as this. And now this isn't probably mathematically correct, but just for this demonstration, I'm just going to add the circumferences of the two circles together. So I'm going to return 1.4 times 2 times C radius plus R radius 2. Alright, so that's everything for rings. So if we go back to our main, let's make this array size 4 now, and let's add a ring to it. So 4. Ring constructor, we'll do 1 and 2. And shape. Alright, so if we run this now, you can see one thing we also should do is we should override the type in the ring constructor just so we can see better what's going on. So we'll do ring shape type equals ring. Not the most efficient way to do it, but this will work. Alright, so now we're back, and now we have ring. So now what if we want an array of circles? So let's go circle equals now. Now let's make it 2. So I'm going to do circ, because remember a ring is also a circle, so circle constructor We'll just do 1. And then we can do circ 1 equals, we'll do 1 and we'll do 0.5 this time, and then we'll just get the circle object. Now if we want to print these out, I'm just going to copy this right here. It's less than 2. So I'm going to do circ shape type, circ, I'm just going to do circumference instead. So circ I, circle F, get circumference. And now we need to pass in the shape object. So alright, so if we do that, alright, so everything works. We can use polymorphism to treat circle as a circle or ring as a circle, and everything works up there. So that's it for this tutorial. If you want me to explain anything further or include anything else in a future episode, just let me know in the comments, and be sure to like this video and subscribe.